Hello, it's dumplet here. Here's an item on geometry. Given this triangle ABC with side lengths 3, 4, and 5 as shown in the figure, and let D be a point inside triangle ABC, find the minimum value of AD squared plus BD squared plus CD squared. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Now, we have this triangle over here. Sides are 3, 4, and 5. I think we've seen this triangle a lot of times. You guys can always verify using the Pythagorean theorem that this triangle must be a right one. So angle A here must be a right angle since 3 squared plus 4 squared is indeed equal to 5 squared, and BC over here, the side with length 5, that's going to be the hypotenuse. So this angle is going to be right. Okay, so we have a lot of straight lines, right angles, and it is pretty interesting that we are getting not like the minimum value of AD plus BD plus CD, but instead the sum of the squares of AD, BD, and CD. Now this kind of motivates me to put stuff into the Cartesian plane, because AD squared, BD squared, CD squared, yes, we're going to use the distance formula, but we can eliminate the annoying square root. So let's try to put this into the Cartesian plane and work on the problem using probably the distance formula. So we're going to label some points. So let's just say point A is the origin. Now point B, let's just say that 3, 0. Point C at 0, 4. So A, B, C are at these 3 points. And then point D, we have no idea where it is because it's just a random point inside the triangle. So we can just make it x, y. So x comma y, that's going to be the coordinate for D. But here's where the motivation comes in. We're getting the sum of the squares of AD, BD, and CD. So there won't be annoying square roots for the distances because this is technically Pythagorean. So the distance formula is technically Pythagorean. So AD squared, just use the distance formula. It's going to be x squared plus y squared. BD squared becomes x minus 3 squared plus y squared, and CD squared becomes x squared and y minus 4 squared. All right, so now I try to observe on that thing. So we want the minimum value of this one, so I kind of expanded it and collected the like terms. So x minus 3 squared, that's going to become x squared minus 6x plus 9. Y minus 4 squared becomes y squared minus 8y plus 16. Collecting the like terms, I have 3x squareds here and then 3y squareds, and then the 9 and the 16 go together. So essentially we have a new question. We just want to find the minimum value of this expression. Well, obviously x and y are real numbers. So this is a very common question in a lot of competitions, and we might want to use the completing the square method. Because x and y are real numbers and we have perfect squares here, we're motivated to complete some squares and see what we can do here. So for the blue terms, I can factor out the 3, and to complete the square, I'll have to do plus 1 inside the parentheses so that this becomes a perfect square. So in effect, I'm adding 3. So to not change the value, let's subtract 3 over here. And then same thing for the green one over here. To complete this square, I would have to add 16 over 9. So in effect, I'm adding 3 times 16 over 9. That's going to be 16 over 3. So let's subtract 16 over 3 for a good measure. Now, this is already a perfect square because this is 3 times the square of x minus 1. And then the second one is 3 times the square of the square of y minus 4/3. And then it's just a 25 minus 3 minus 16 over 3. Now, since we have perfect squares here, we know that this is going to be at least 0. This is going to be at least 0. Now, if we want to find the minimum value, we must have x equals 1 and y equals 4/3. Now, we have the values of x and y, which we can, if we're interested in getting the point D, we have the coordinates for that. But for the question, since we want to find the minimum possible value of AD squared plus BD squared plus CD squared, that's going to become 25 minus 3 minus 16 over 9, because it is this part outside other than these two these non-negative terms. So 25 minus 3 minus 16 over 9, that's going to become 50 over 3. And this will indeed be our final answer. Now, just a little bit bonus here. X equals 1 and y equals 4/3. That's when the minimum value is attained. So we know that the coordinates of D, which we set a while ago to be xy, that's going to be at 1 and 1, 4/3. Now, it's kind of interesting because 1 and 4/3, they're exactly 1/3 of the two legs. So it's 1/3 of 3 and a 1/3 of 4. Now, I'm going to tell you that that's always the case, but if you want to prove it yourself or find any interesting properties related to dividing the legs by 1/3 to get like the coordinates of the point D over here, you guys can try to make some nice observations there. But anyways, hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.